To start this PC build, we'll first need a parts list. The major components are the CPU, motherboard, RAM, SSD, power supply unit, AIO, GPU, fans and of course the PC case. Let's talk about RAM. Random access memory, commonly known as RAM, is a crucial component in computer systems that plays a fundamental role in their overall performance. Unlike permanent storage devices such as hard drives or SSDs, RAM is volatile memory that temporarily stores data and machine code that the CPU, central processing unit, actively uses during a computer's operation. The primary function of RAM is to store data and instructions that the CPU requires in real time to execute tasks. When you open an application or run a program, the operating system loads the necessary data into the RAM, allowing the CPU to retrieve and process it quickly. The more RAM a computer has, the more data it can store for quick access, reducing the need to fetch information from slower storage devices. RAM is volatile, meaning it loses its stored data when the power is turned off. This characteristic makes it unsuitable for permanent storage but ideal for temporary and fast data access. The computer constantly transfers data between RAM and permanent storage devices like hard drives to mitigate the volatility. A solid-state drive, SSD, is a data storage device that has become a staple in modern computing, providing significant advantages over traditional hard disk drives, HDDs. Unlike HDDs, which use spinning magnetic disks to read and write data, SSDs use NAND-based flash memory to store information. This distinction in technology brings about several vital benefits contributing to improved performance, durability, and energy efficiency in computing systems. The primary advantage of SSDs lies in their speed. Unlike the mechanical components of HDDs that require time to spin up and position read-write heads, SSDs have no moving parts. This enables them to access and retrieve data quickly, significantly reducing boot times, application loading times, and overall system responsiveness. The absence of mechanical components also makes SSDs more resistant to physical shocks and vibrations, enhancing their durability and reliability. In addition to their speed and efficiency, SSDs are crucial in improving the overall user experience by reducing noise levels associated with traditional HDDs. The silent operation of SSDs contributes to a quieter computing environment, particularly when noise reduction is desired. While SSDs offer numerous advantages, it's essential to note that they are generally more expensive per gigabyte compared to HDDs. However, the decreasing cost of SSDs over time and their undeniable performance benefits have led to their widespread adoption in various computing devices, from laptops to servers, revolutionizing data storage in the digital age. Now let's move on to the power supply unit. PSU is a critical component in a computer system responsible for converting electrical power from an external source, typically a wall outlet, into the required voltage and current formats needed to operate the computer's internal components. It is the primary link between the electrical grid and the elements that comprise the computer, ensuring a stable and reliable power source for optimal system performance. PSUs provide different voltage levels required by various components within the computer, such as the motherboard, graphics card, hard drives, and other peripherals. The most common standard for consumer-grade PSUs is the ATX, Advanced Technology Extended, form factor, ensuring compatibility with various computer cases and motherboards. PSUs are characterized by their power output, measured in watts. The power requirements of a computer depend on its components, with more powerful systems, such as gaming PCs or workstations, demanding higher wattage PSUs. It's crucial to choose a PSU with sufficient power capacity to meet the demands of the components while allowing for future upgrades. Now, let's get into the CPU and motherboard. CPUs, or central processing units, are the primary component of a computer responsible for executing instructions from programs. CPUs perform various operations, including arithmetic, logic, and input-output functions, which are essential for running applications and software. The clock speed of a CPU, measured in GHz, determines how many instructions the CPU can execute per second, impacting overall performance. There are various types of CPUs, including single-core, dual-core, quad-core, and beyond, each offering different levels of performance and capabilities. CPU architecture encompasses the design and layout of internal components, such as the control unit, arithmetic logic unit, and cache memory. Motherboards serve as the main circuit board in a computer, providing the platform for CPU, memory, and connectivity components. Motherboards come in various form factors, such as ATX, Micro ATX, and Mini ITX, determining the physical dimensions and layout of the board. The basic input-output system, BIOS, or the Unified Extensible Firmware Interface, UEFI, on a motherboard is responsible for initializing hardware components during the boot process. Motherboards feature slots for components like CPU, RAM, expansion cards, and connectors for peripherals such as USB, audio, and networking devices. USB 3.1 offers faster data transfer rates and enhanced power delivery compared to its predecessors. M.2 slots enable high-speed connections for NVMe storage devices, enhancing system performance. Motherboards with overclocking support allow users to boost CPU and memory speeds for enhanced performance. Ensuring compatibility between the CPU socket type, chipset, and motherboard form factor is essential for successful system integration. Factors affecting performance include the CPU's processing power, the motherboard's support for overclocking, and the speed and capacity of system memory. Upgrading to a motherboard with support for the latest CPU technologies ensures better performance, compatibility with new software, and longer useful life for the system. The CPU and motherboard form the foundation of a computer system, impacting its speed, capabilities, and compatibility with various hardware and software. Continuous advancements in CPU and motherboard technologies drive improvements in computer performance, efficiency, and overall user experience. The seamless integration of compatible CPUs and motherboards is critical for maximizing the potential of computer systems and achieving optimal performance. Now, we will be getting into computer fans and the PC case. Case fans, also known as computer fans or chassis fans, are vital components in a computer's cooling system. They play a pivotal role in managing temperature and dissipating the heat generated by internal components like the CPU, GPU, PSU, and storage devices. Cooling is essential for a computer because electronic components, such as the Central Processing Unit, CPU, and Graphics Processing Unit, GPU, generate heat during operation. If this heat is not efficiently removed, it can cause the components to overheat, leading to performance degradation, instability, or permanent damage. Cooling systems like computer fans help regulate the temperature, ensuring optimal performance and longevity of the hardware. Case fans. These fans are installed in the computer case and help circulate air throughout the enclosure, maintaining a consistent temperature for all components. Central Processing Unit, CPU, fans. CPU fans are specifically designed to cool down the processor. They are typically mounted directly on top of the CPU, dissipating heat generated by the processor's operation. Graphics Processing Unit, GPU, fans. Similar to Central Processing Unit, CPU, fans, GPU fans are dedicated to cooling graphics cards, which often have powerful processors and generate substantial heat during intensive graphical tasks. Liquid cooling fans. In liquid cooling systems, fans are used to cool down the liquid coolant flowing through the system. These fans are usually part of a radiator that dissipates heat from the liquid. Laptop cooling fans. Laptop cooling fans are smaller fans designed to cool down the internal components of a laptop. They help prevent overheating in confined spaces and maintain optimal performance. So why are fans so important? Temperature control. Well-placed fans help manage temperature by directing airflow to critical components such as the CPU and GPU, preventing overheating. Dust management. Proper fan placement can help prevent dust buildup by ensuring that air is drawn in through filters and expelled, minimizing the accumulation of dust on internal components. Noise reduction. Correctly configured fans can help reduce noise by providing efficient cooling, allowing you to maintain a quiet PC environment. So what is a GPU? Graphics rendering. GPUs render images, videos, and animations by processing complex mathematical calculations. Parallel processing. GPUs excel at executing multiple tasks simultaneously, making them ideal for highly parallelizable workloads such as deep learning and video encoding. Compute tasks. Beyond graphics, GPUs are utilized for scientific calculations, financial modeling, and other computational tasks due to their immense processing power. One thing that GPUs need is thermal paste. As GPUs perform intensive computations, they generate significant amounts of heat. Effective thermal management is crucial to prevent overheating, which can lead to performance throttling, instability, and even hardware damage. Thermal paste plays a vital role in dissipating heat efficiently from the GPU to the heatsink and ultimately to the surrounding environment. Applying an appropriate amount of thermal paste is essential for optimal heat dissipation. The pea-sized, or grain of rice, method is commonly used, where a small amount of paste is placed in the center of the GPU before mounting the heatsink. Excessive thermal paste can impede heat transfer, while insufficient paste may leave air gaps. Thus, precision and moderation are key. At the end of the day, building a PC can be very labor-intensive. It can also be very personal. Each component is hand-picked and placed by you. All parts should be compatible with each other, and the unit should run without issues once assembled. To assemble all the components, install the CPU, RAM, GPU, and storage on the motherboard. Connect the PSU, ensuring all components receive power. Place the motherboard in the case and secure it. Connect case fans, power, reset buttons, and front panel connectors. Cable management. Organize cables to improve airflow and aesthetics. Route cables behind the motherboard tray and use cable ties to secure them. Ensure all components are securely connected. Install operating system. Insert your OS installation media, USB, DVD, and follow the on-screen instructions. Install drivers for your motherboard, GPU, and other peripherals from the manufacturer's websites. Update drivers and BIOS. Visit the motherboard and GPU manufacturer's websites to download the latest drivers. Check for BIOS updates to enhance system stability and compatibility. Test and monitor. Power on your PC and check for errors. Monitor temperatures using software like HW Monitor. Run stress tests to ensure stability and adjust settings if needed. Building a PC requires attention to detail and patience. Follow the component manuals and online resources for specific instructions. Enjoy the process and the satisfaction of a custom-built system tailored to your needs.